Okay, so last week we talked about area, and remember, when you find the area, this stems off of Chapter 5. In Chapter 5, back in Cal 1, what we did is we had one basic curve and we found the area underneath the curve. Well, now what's going on is we have two or more curves, graphs, and what we're trying to do is we're trying to find the area between those graphs. And so we kind of step it up a notch. And if you printed off your formulas, we are talking about the first two formulas on your formulas page. And so you have an R sub x region, and if you'll remember, in your R sub x region, you are going to have your x boundaries and you want x variables. So you want x boundaries and you want x variables. Well, the boundaries are going to be the x values. If you're doing an R sub x region, your boundaries are going to be the x values of where these graphs intersect. So, for example, this graph that we drew, it intersects here and it also intersects here. So your boundaries are going to be from 0 to 1. Now, you can figure that out algebraically. I don't know that we did that. Yes, we did. Algebraically, you can just take the two equations, set them equal to each other, and solve, and you can find your boundaries that way. Now, the only time that you can do that is if the two graphs actually intersect. We will do one tonight where the graph does not intersect, so you can't really do that. Alright, but this one does obviously intersect, so our x boundaries are going to be from 0 to 1, so we're going to integrate from 0 to 1. And remember, it's always a minus, or from a to b, so you always want to work from left to right. Since this is an R sub x region, since this is an R sub x region, I am going to do top minus bottom. Okay? It's going to be top minus bottom. And so that's how we set this up. What we did is we took this graph, and you can see that the top, because this little bitty green area, that's the area that I'm trying to find. So you take the top part of that little area, and you notice that that is going to be your parabola. Well, that's your x squared term. So it's going to be top, which is this one, minus bottom. Now, since this is an R sub x region, since we chose our boundaries off of the x axis, you don't want anything over here except x variables. So what you're going to have to do is you're going to have to take this equation and solve it for y. You want y equals, and you want your x variables. So in here you have your x variables and your constant. Same thing for this one. Your bottom graph is going to be the line. And so what you want to do is you want to take your line and you want to solve it for y again, so that when you plug it in, you only have x variables and your constant. So this was our setup. Okay? So we have top of the graph minus bottom of the graph. We have our x boundaries, x variables. Just keep that in mind. If you're going to do an R sub x region, you want x variables and x boundaries. Well, from there, what we're going to have to do is we're going to have to do a little bit of algebra. So you can take the minus through however you want to do it. I want to put it in descending order, so we're going to have x squared. And then the x is going to come next, so we'll have plus x. And then 3 minus 3, that's going to go away. So those are just going to cancel out. All right, and then we're going to evaluate that for dx. So we have the integral from 0 to 1. Let's go ahead and integrate. So let's do this. Negative x to the third over 3 plus x squared over 2. And we're going to integrate from 0 to 1. Okay? So now all we have to do on this one, you're going to plug the 1 in. So you have negative 1 cubed over 3 plus 1 squared over 2. And then, of course, minus, and it's going to be 0 because both of those, when you plug 0 into both of those, it turns it into 0. So that really doesn't come into play. But basically what you're going to have is negative 1/3 plus 1/2. And when you put that in your calculator, you come up with 1/6. Now, remember I told you when you were doing these, check for reasonable answers. Check for reasonable answers. And when I say that, this is what I'm talking about. This is a little bitty area. Okay, it doesn't even cover a full, if it was on a square, it wouldn't even cover a full square. And so this 1/6 is a small amount of a square. So yeah, small area would be small amount. So I think it's reasonable. All right. So do you know if you're looking at an R sub X region or an R sub Y region? Could you be able to pick out, am I looking at an R sub X or am I looking at an R sub Y? That's the hardest part about this. Because once you know you're looking at an R sub X versus an R sub Y, you can go to your formulas page and just take out the formula. Okay? So let's look at another one. Let's look at this one. For this one it says, find the area of the region bounded by y equals x squared plus 2, y equals x, x equals 0, and x equals 2. Now this time I've given you 4 graphs. But only 2 of the graphs are going to come into play. The other 2 are kind of sort of boundaries for you, okay? Let's graph this. You know that y equals x squared plus 2. Y equals x squared plus 2. If you do not know how to graph these, you can always fall back on a t-chart. Okay? Y equals x squared plus 2 is going to be a parabola, and that parabola is going to be shifted up 2. So it's going to have a vertex there. And then if I plug in 1, I should get 3. And if I plug in negative 1, I should get 3. If I plug in 2, I should get, 6? So that's going to be way up here. And negative 2 is going to give me 6 also. All right, so here's your parabola. The next thing we have is a line, y equals x. So y equals x is just going to be this line that does this. And then you have x equals 0. X equals 0 is just going to be your y-axis. And you have x equals 2, which is going to be a vertical line going through the y-axis at 2. So, what region am I talking about? Well, I'm talking about this region right here. I want to find the area of this stuff right here. Okay, so you tell me, are we looking at a R sub X region, or are we looking at an R sub Y region? What do you think? Let's go back and look at it. If we're doing an R sub X region, what we're going to do is we're going to get boundaries off of the x-axis. And we're going to plug in our functions we're going to basically integrate from top to bottom. Okay? If we're looking at an R sub Y, our boundaries are going to be off of the y-axis. And then we're going to integrate from right to left. So which one do you think you're looking at? Do you think you're looking at a top minus bottom or a right minus left? You could do it both, but you pick one. Which one of the boundaries would be easier to pick up? Would it be easier to pick the x boundaries or the y boundaries? It'd be easier to pick the x boundaries, would it not? So let's go that route. So what are your x boundaries? 2. Always going to go A to B. Okay, since we chose x boundaries, we have to have x variables, and we're going to do top minus bottom. Top minus bottom. So what is the top graph? Right, so we're going to have x squared plus 2 minus the bottom graph. What's the bottom graph? Y equals x, so we just need the x dx. Okay? So the integration for this one is just going to be easier if you have an r sub x region. So there is your setup. Let's see if you can actually do the integration. So again, as always, let's do the algebra first. Basically, for this one, all we need to do is put it in descending order, and that's about all you can do. Okay, so the integration comes next, so we'll raise, square goes to third, and we'll divide by 3. This will go to 2 and divide by 2, and this simply goes to 2x. And we're going to integrate from 0 to 2. Did you do your integration correct? Any questions on that? 2x what? Are we good? Okay. So again, let's plug the 2 in. So we'll have 2 cubed divided by 3 minus 2 squared divided by 2 plus 2 times 2. And then, of course, minus when you plug 0 in for all of those. Now, that's not always going to happen, so don't take that for granted. So make sure you look at that. But anyway, so what we're going to have is what? 8/3 minus 4/2, which, of course, is going to reduce, plus 4. Plug all that into your calculator, and hopefully you came up with 14/3. Now we're talking about area, so since we're talking about area, we're talking about 2 dimensions. And back when you were doing maybe geometry, or 7th and 8th grade math, anytime you found an area, for example, an area of a rectangle, base times height, length times width, whatever, what happened to your units? They get squared, okay? So if you're finding area, you are going to have square units, and we are talking about 2 dimensionals, okay? Because tonight we're going to talk about 3 dimensionals also. So it is 14/3, and of course it would be units squared if we had a real world problem up here. All right, let's look at this one. So for this one, we have y equals x to the 3rd. Do you remember what graph that is? It's the S-curve, isn't it? Okay. And then you have y equals x squared. What is y equals x squared? We're talking about this little area right here. Well, just want to make sure you know your graphs. If you know your graphs, you're good. If you don't know the graphs, you can do this algebraically, and we'll look at one that has trig in it, and you can figure it out trigonometrically also. But for this one, you need to decide, do you want to do an r sub x or an r sub y? Do you want to integrate top minus bottom or right minus left? Look at your equations because they can help you a little bit. I would say top minus bottom, simply because that's the way your equations are set up. Not to mention the fact we can also figure out our boundaries. Fairly simple, right? Now watch this. I do want to draw your attention to this. The easy way out. So my question is this. If we're going to do an R sub x region, I need x boundaries. Can you look at this and tell me what the x boundaries for sure are going to be? What would your guess be? A guess would be 0 to 1. Can you tell me for sure? Algebraically. Well, okay, 0 for sure. I'll give you that one. 1 is in question. They do. And technically they both pass through 1, 1 also. But let's just say that we didn't know. Let's do this. You can always figure out your boundaries algebraically. Always. Okay? Take these two and set them equal to each other. In order to do that, in order to set them equal to each other, you either have to solve for y's or you have to solve for x's. That's your choice. Since the y's are already solved for, I'm just going to go with that. So we're going to have x cubed minus x squared is equal to 0. Do you know where to go from here? This is algebra. Where would we go? Factor. Let's factor out an x squared. And take each one of those and set them equal to 0. And so we're going to get x is equal to 0 and x is equal to 1. So there's your boundaries. Your boundaries are, in fact, 0 to 1. So if you ever are concerned about figuring out what your boundaries are going to be, use algebra. You can use algebra to figure them out. Okay, since we chose x boundaries, remember when you're using your R sub x region, it's always going to be top minus bottom. So if we go to this little bitty area right here, which one's on top? The parabola's on top. So you got to make sure your graphs are pretty good, right? So we're going to put the parabola on top, minus the bottom, which of course is going to be the Superman curve. And then we're going to integrate with respect to x. Alright, so work on it. See what you come up with. And so you should come out with 112. Happy day? Definitely pull your calculators out. Definitely going to be needing those. Alright, let's try another one. Look at this one and see what you want to do. First thing you're going to do, if you are a systematic person and you want steps, step number 1, I wrote it on the board for you last week. Graph it. Very first thing that you want to do, if you cannot look, okay, let me say this. If you can look at all of these graphs and tell which region you're going to be, R sub x or R sub y, and you can also look and see what your boundaries are going to be, and you can also look and see which one's going to be top or bottom or right or left, depending on which region you chose, then don't graph it. I, for one, cannot do that. I have to graph it in order. I'm a visual learner, and so I have to graph it in order to know what's going on. If you know what's going on without having to graph it, fine. Don't graph it. But I cannot do that. Okay. So the first one we have is x is equal to y squared. Now that's backwards to what you're thinking, right? Most people look at that and say, oh, well, that's just your parabola. It's a parabola, but it's not your normal parabola. What is this parabola doing? Yeah. This one is going to be symmetrical about the x-axis, whereas our normal parabolas are symmetrical about the y. This one's going to be symmetrical about the x-axis. So if you want to plot your points and draw your parabola, you can. But when you do that, if you need to do a t-chart, that's fine. This time what you're going to say is if y is 2, then x is going to be 4. And so that's how that one's going to go. All right, and the other one, you have y minus x is equal to 2. You have a choice here. You can put it in slope-intercept form if you want to, or you can graph it by using intercepts. That's completely and totally your choice. Since it's in standard form, I'm just going to use intercepts. I can cover up that negative x, and I know that y is equal to 2. I can cover up that y, and I know that x is equal to negative 2. And so there's that line. Now, I have two other boundaries, if you want to call them that. You have y is equal to negative 2, which is a horizontal line going through the y-axis at negative 2. And then you have y is equal to 3, which is a horizontal line going through the y-axis at 3. So can you tell what your region is? Do you see your region that's bounded by all 4 of the graphs? What's that right there? Okay, so we have our graph. Now, let's talk about our region. If we choose an R sub x region, we have to have x boundaries, yes? Okay, let's look at this. If we have an x boundary, we're going to have one here. Don't know where it is, we can figure it out though. We're also going to have one here. Don't know exactly where it is, but we can figure it out. We're also going to have one there, and we're also going to have one there. How in the world would you integrate an R sub x region with 4 boundaries? It's doable. Not suggested, but it is doable. You would have to do this region, and then you would have to turn around and do that region. And you can do that if you want to. And then add them together. You would integrate and then add them together. But watch this. If we did an R sub y region, we would need y boundaries. Do you see 2 y boundaries? Yeah, here and there. They gave you 2 y boundaries in the problem. So it would be logical to use a R sub y region. All right, so if we use an R sub y region, our boundaries are going to be negative 2 to 3. Now, remember when you do an R sub y, you're not doing top minus bottom anymore, you're doing right minus left. Okay? So what is your right side graph? The parabola. And when you write in your f sub y, g sub y, when you write in your function, you only want y variables and constants. Okay? So my right side graph is this one right here. This is the right. And I only want that y squared. So you have to solve for x. So we're going to put in y squared minus left side. Left side is going to be that line y minus x squared. Well, there's a problem there. What do I need to do in order to plug it into my integral? I need to solve for x. I need the y and the constant on the same side. So if I solve for x, it's going to be x is equal to what? So now let's clean this up a little bit, and then we will actually integrate. Let's just put it in descending order and distribute that negative all the way through. And now we can actually do the integration. Now, do you see a difference with this problem with from the previous problems? You have to do the last part. Our lower boundary is not 0 this time. Our lower boundary this time is -2. Just a little more math, a little more calculator work. Not that big of a deal. As long as you got your calculator in front of you, you should be fine. But just remember, when you plug in this definite integral, you're going to plug in the top minus the bottom. And since the bottom is a negative number, please be careful with that negative sign. All right, see if you can come up with an answer for me. Very good. And your calculator is probably going to spit at you, and I will take either one of those. I'll take 19 and 1/6, or I'll take 115/6. Either way, and it is units squared. You don't have to write the units squared. Actually, on a test, for those of you who ever did math team, it gets better to not put the units. Because if you put units cubed, then you have to let it roll. So just leave a unit roll. Questions? Are we good? This is the first R sub y region. Is it kind of coming clear on how to choose? Or am I looking at an R sub x, or am I looking at an R sub y? The more you do, the easier it's going to become. Okay, just make sure you practice. That's why I give you all those problems. Make sure you practice this. Any questions? All right. If you're having a problem with your calculator, it's probably that stinking -2. So just make sure you use parentheses when you plug in that -2. And the reason I say that, on the cube, it's not going to matter. It's going to be -80 regardless. But on the square, if you don't use the parentheses, your calculator is going to give you a -4 instead of a +4. So be careful with that. Okay, let's look at this one. This one, it's not a hard calculus problem, it's a hard graphing problem, but it's kind of a necessity to know what the graph is doing in order to be able to do the integration part. So, let's think about how to do x equals y to the 2/3. That's basically the cube root of y squared. Does anybody know how to graph that? Let's look. All right, we came up with 0, 0. We came up with 1, 1. We came up with 1, -1. So it's definitely not a straight line. We came up with 4, 8. And we came up with 4, -8. It's not a V. It is kind of like butterfly antenna. Okay, so that's your x equals y y to the 2/3. Now, x equals y squared. We've done that all night long, right? X equals y squared is this parabola. So what are we talking about? We're talking about this region, and we're talking about this region. Now, according to my graph, you can't really tell it, but based on your knowledge of parabolas and fractional graphs, they are symmetrical. They are symmetrical, okay? And again, I apologize, but you can't really tell it from my graph, but these are symmetrical. That graph is so tiny, I should have made it like the other ones, but this graph technically should go from here to here, and this graph technically should go from here to here. So this is one of those ones where the graph, aside from visually figuring out if it's going to be an r sub x or r sub y, the graph's really not going to be that much. Because the boundaries on this one looks like the boundaries is going to be from 0 to, I don't know, something else. Okay? So it's going to be kind of difficult. We are going to use symmetry. Yes. We are going to use symmetry because of what we said. Both of these graphs are symmetrical. Okay. Since both of these graphs are symmetrical and they do have intersecting points, we are going to use symmetry. Now, do you remember how to do symmetry on an integral? I'll take that as a no. It's going to be 2 times your integral. But you're not going to go all the way from bottom to top or right to left. Instead, you're only going to go halfway. Okay? So now we need to decide, are we going to go right to left or top to bottom? Look at your equations. Well, it's all for x in terms of y, right? So I think I would just go with that. Since I've already got my equations in terms of y, I think I would just go with that. Okay, we can do this. Let's do some algebra. This is crazy. Now what? You have y squared is equal to y to the 2/3. What are you going to do? You can take out a y to the 2/3. Always take out the smaller amount. So we'll do y to the 2/3. Well, what is 2 minus 2/3? I don't know where I put that in. But yeah. All right. Either way, if you take both of these and set them equal to 0, you're going to get y is equal to 0, and you're going to get y is equal to 1. So there's your boundaries. But understand, we're only doing part of it. We're only doing from here to here. And again, based on that graph, it doesn't even look right. Okay. So since we're going to do an r sub y region, we have y boundaries. What do we need in our integral? Y boundaries and y variables. Y boundaries and y variables. Okay, if we are doing an r sub y, are we doing top minus bottom or right minus left? We're doing right minus left. So which one's going to be on the right? Y to the 2/3, good. Minus y squared. And we're going to integrate with respect to y. So you have dy. Now, could you have done an r sub x region? Sure. You would have just had to take those and solve them for y. Take your equations, solve them for y, set them equal to each other, and gone that way. All right, let's integrate. So we're going to have 2 times. So this is going to be what? Y to the 5/3 divided by 5/3 minus y to the 3rd divided by 3, integrated from 0 to 1. What's the first fraction going to turn into? If you plug 1 in. If you plug 1 in for y, cube root of 1 is 1, and 1 to the 5th power is 1. And then 1 over 5/3, or 1 divided by 5/3, is going to be 3/5. Multiply by that reciprocal. Minus, again, if you plug 1 in for the second one, you're going to have y cubed, or 1 cubed, which is 1 over 3, which is going to be 1/3. And then the 0 is going to turn into 0, so we're not even going to worry about it. So we're going to have 2 times 3/5 minus 1/3. Got your calculators out? Four 4/15. Finish it up, and you should come up with 8/15. All right, so it is good to know those little algebra tips. Now, what if you graph these and you have no idea which one's on top and which one's on bottom? And the reason I say that is because what if we have graphs such as this one? What if you can't tell by this graph which one's on top and which one's on bottom? What are you going to do? Well, the first thing you want to do is you want to find your boundaries. That you can do with the algebra, right? And then what you want to do is you want to pick a number in between your boundaries, okay? So if your boundaries are from 0 to 1, pick a number between 0 to 1. What would you say? 0.5. Okay, so this is what you're going to do. You're going to take your 0.5, pick that number between your boundaries, and like I said, if we choose 0.5. If we plug 0.5 in for this one, you're going to get y is equal to what? 0.125 or 1/8. If we take this one and we plug in 0.5, we're going to get 0.25. Which number is bigger? 0.25. 1/4 is bigger than 1/8, right? So that's how I know whichever one gives you the bigger value, that's going to be the one that's on top. Or whichever one gives you the bigger value, if you're doing right minus left, that's the one that's going to be on the right. Okay? So if you graph these and you can't tell which one's on top or which one's on the farther right, pick a number between your boundaries, plug it in, whichever number gives you the biggest value, that's the one that's going to come first. Okay? So just a little hint for you, just a little tip. When you start graphing these and you can't figure it out. Okay, as promised, let's talk about the one that has the trig. Now, if I had to guess, about maybe 25% of you would know how to graph this. Maybe 25% of you would know how to graph these two trig equations. If you have y equals 4 plus cosine 2x, well, we know that cosine ranges from what to what on the y-axis? negative 1. Your typical cosine ranges from 1 to negative 1, and you know that it does that, right? Your sine curve ranges from what? 1 to negative 1 also, but it doesn't start at 1, it starts at 0, right? And so your sine curve does that. But we don't have just a basic cosine curve, and we don't have just a basic sine curve. If we did, that would be your graph. That's not what we have. Instead, and I'm going to erase all this in a minute, so instead what we have is 4 plus cosine 2x. So what we're doing is we're taking our basic cosine curve, this one here, we're taking our basic cosine curve and we're moving its apex, its central region, up how many units? 4. So we're taking our cosine curve and we're moving it up 4. So now it's going to range from what to what? 5 to 3. But we don't have cosine x. We have cosine 2x, which means we've got to fit 2. It's a double angle. We've got to fit 2 cosine curves from 0 to 2 pi, even though we're going from 0 to pi. So that's going to make it go really, really tiny. Okay? And this is going to be pi. We're not going to go to 2 pi. Okay, let's take our sine curve. For the sine curve, that's going to be this one. For our sine curve, we have 3 sine 1/2 x, which means our amplitude is 3. That's how high and low that thing goes. So since it's 3, that means it's going to be squished. And I can't have one sine curve. I can't have a full sine curve from 0 to 2 pi. I have to have a half of a sine curve stretched from 0 to 2 pi. So not only is this thing, half of it, stretched out, it's also squished because of the 3. So this one is going to do this. Just going to get some of it. And that's why you have a boundary from 0 to pi. Because these two things, if you drew them all the way out to infinity, they'd never intersect. So what we've done is we've given you boundaries, and I want to know the area of the region. That looks like that right there. Now, half of you are probably ready to throw up because you're thinking, I'm not going to be able to do that on the test. I'm not going to ask you to do that on the test. I'm not going to ask you to graph this on the test. Think about it, okay? In order to find the area between two curves, you need to figure out, am I going to do an R sub x region or an R sub y region? If you did not have these graphs up here, but you had those boundaries from 0 to pi, then it should be obvious what your boundaries are. Okay? So you don't need a graph. So I know what my boundaries are going to be. Okay? So that's the first thing you got to do. When you're looking at this, you got to figure out, are we doing R sub x or R sub y? So obviously we're doing R sub x, yes? Because there's your boundaries. Since I'm doing R sub x, okay. Look at your two equations. Since you're doing R sub x, what variables do you need when you plug into your integral? X. Well, look. They're already there. Okay? Step number 3. I got to figure out which one's on top and which one's on bottom. If I had not have done this, what's the only, both of these range, because this is kind of some true that you do need to know. Both of these range from 1 to negative 1, but one of them shifted up 4. and the other one's still at 0. One of them is shifted up 4, and it goes around 4, and the other one stayed at 0 and it's going around 0. So which one's going to be the top? The one that shifted up 4. Okay? So as long as you know your shifts, you should know which one's on top and which one's on bottom. Okay? So without the graphs, you don't have to graph it. You should know what's going on. I'm giving you boundaries. Now, if I had given you a boundary from 0 to 1 for trig, okay, there's a little bit of trig that you need to know. If I give you from 0 to pi boundaries, or 0 to 2 pi, if I give you radian measures, we're talking about x, right? If I give you numerical values, we're talking about y. So if I had given you a boundary from 0 to 1, you know we're talking about y. Okay? All right, so I gave you the boundaries. The boundaries are going to be from 0 to pi. From 0 to pi, and then you're going to do top, which is the one that shifted up 4, minus bottom. So for this one, when you look at this one, don't feel like you want to throw up. Just take a step back, breathe, and think about it. Okay? I'm giving you the boundaries, which it should be a huge hint as to which variables you need, which should also clue you into saying, well, one of them is going to be shifted up. Now, if both of them sat about the 0, that'd make it a little bit more difficult, right? But I'm going to shift one, so don't worry about it. All right, so let's start this. So we're going to go again from 0 to pi. Now, with this trig, there's nothing that you can combine. So we're going to integrate this whole entire thing with respect to x. Now, just like on the, look at the previous problem that we just did. When I asked you to integrate algebraic terms that were just separated with plus and minus signs, how did you do this? You integrated each one of them separately, right? Well, this is what you're doing. You're integrating trigonometric terms that's just separated by plus and minus signs. So this is what you're going to do. You're going to integrate from 0 to pi 4 dx plus integrate 0 to pi cosine 2x minus, I'm going to move that constant out front. Y'all should have learned that in Cal 1. And all of these with respect to dx. We're going to integrate each individual one with respect to x. Okay? So that should make it a little less overwhelming, right? So if I integrate 4, what is the antiderivative of 4? Yeah. What is the antiderivative of cosine 2x? Where's 1/2 come from, Maggie? Okay. Well, we don't really have the chain rule. I know what you're talking about. Use substitution. Because what's going to happen is this. If you're sitting on the test and you want to know how to integrate cosine 2x, hopefully, you're going to pull this sheet from Cal 1 out. And you're going to look down through there, and you're going to look at number 2, and you're going to see cosine u du. And this is what I want you to remember. I tried to drill it into your brains in Cal 1. U is the same as x. I don't have cosine x. I don't have cosine u. I have cosine 2u, or cosine 2x. And I don't know how to integrate that. You do not, listen to me carefully, you do not know how to integrate a true function unless your argument is just x. Okay? We don't have just x. We have 2x. What do we have to do? U substitution. What is u? So what is du? But I don't need 2 dx, I just need dx. So now I'm going to have 1/2 the integral, and now I have cosine u du. So, making our substitution, we have 1/2. What is the integral of cosine u? Sine u, but u is 2x, minus. Okay? What is the antiderivative, the integral, of sine 1/2 x? Do you know how to integrate sine 1/2 x? Is it just negative cosine? No. Because we don't have just x. We have 1/2 x. So you have to do u substitution one more time. So if we do the integral of 0 to pi of sine 1/2 x, u is going to be 1/2 x. So du is going to be 1/2 dx, but I don't need 1/2 dx, I just need dx. So 2 du is dx. Okay, if I could write. Alright, so go back and I need a view there. Alright, so, but we have to multiply 2 times 3, right? So you're going to have -6. And then the antiderivative of sine u is going to be negative cosine u. Now, don't let me lose you here, okay? In fact, I'll make it a different color. I want to take that negative and bring it up here. Negative times negative, make it a plus. Are we good with that? Okay. Cosine u, which we said was 1/2 x. And we're going to integrate this from 0 to pi. Okay, so the Cal 1 stuff is done. That's just doing your integration with your u substitution. And please remember, again, I told you this last week, on a test, people are notorious for just straight up integrating this. And they'll tell me that this is 4x, which is fine. But they'll tell me that this is sine 2x. And then they'll tell me that this is 3 cosine 1/2 x. And that's not the case. If your argument is anything but x, you have to have a compensation, which would be the 1/2 and the 2. Okay? Now, at this point, please remember to put your calculators in radian measure, because we're dealing with radians now. Okay? Does everybody know how to put their calculator in radian measure? You should have a degree, radian, and something else. Alright, so let's substitute pi in for x. Everywhere you see an x, you're going to plug pi in. Okay? So we're going to have 4 pi plus 1/2 sine of 2 pi plus 6 of cosine pi over 2. minus. Don't lose the 0. Don't lose the 0. So we're going to have 4 times 0, which of course is 0, plus 1/2 sine of 0, plus 6 cosine of 0. Again, in your calculators, make sure they're in radian measure. 4 pi is just going to be 4 pi for now, okay? But this is what I want you to do. I want you to type in your calculator sine, make sure it's in radian, sine of 2 pi. What is the sine, or you know, your unit circle, your whatever. What is the sine of 2 pi? Where is 2 pi? Where is 2 pi? It's backwards. Where is 2 pi? It's over here at 0, is it not? 0 has an ordered, this has an ordered pair, if you remember your unit circle. It has an ordered pair of 1, 0. Sine is always X or Y. Sine is always Y. Okay? So if you know your unit circle, a little bit of a trig lesson here. Sine is always Y. Cosine is always X. And of course, tangent is always Y over X. This is an ordered pair. This ordered pair is 1, 0 because we're on the unit circle. Okay, so that's 1, 0. This is going to be 0, 1. This is going to be negative 1, 0. And this is going to be 0, negative 1. So, let's go back here. If you don't have your calculator and it's not in radians, sine of 2 pi. Here's 2 pi. This is 0 and 2 pi. Sine is Y. There is Y. So that's going to be 0. Cosine of pi over 2. Cosine is X. Cosine of pi over 2 is what? 0. Sine of 0. What's that going to be? 0. Cosine of 0. Cosine is X, so it's going to be 1. So there's all your numbers. And if you have a calculator and it's in radians, it'll tell you the same thing. Just type in sine of 2 pi. Sine of 2 pi, and it's going to give you 0. Cosine of pi over 2 is going to give you 0. Minus, and of course you have 0. Sine of 0 is going to be 0 again. Cosine of 0 is 1 times 6, which is 6. So you're going to have 4 pi minus 6. Now that I do expect you to know how to do. Clear out the cobwebs. That's all I can say. Who's my timing person? Who's keep that with on? Who did we assign that to? Because we're going to talk about volume. We're going to go from area, which is 2-dimensional, up to volume, which is 3-dimensional. Okay? So, our formulas are going to change a little bit. Now, when we talk about the volume of these 3-dimensional figures, there's going to be multiple ways that we can do this. But the nice thing is you can, on the test, I will tell you, use the disc method, or I'll say use the washer method, or I'll say use the shell method, okay? And once you see that, what you're going to do is you're going to go in your formula page that you need to print off a blackboard. And you'll see the first one is this method, and you have your formulas there. The second one is the washer method, and you have your formulas there. And then the last one is the shell method, and you have your formulas there. Okay? So, I will tell you on the test which one to use, just to make it a little bit easier for you. and then all you have to do is go on your formulas page, find that method, and you'll be good, okay? So the first one we're going to talk about is the DISC method. And what I want you to notice is when we talk about the DISC method, if you'll go in your books on page 315, 314, 315, now on page 314, when you look at figure 618, that's what we just came through and what we did in chapter 5, okay? That is your two-dimensional graph, just find the area under the curve. Well, now what we're going to do is we're going to take that two-dimensional graph and we're going to revolve it. For this one, we're going to revolve it about the x-axis. And I'll tell you also, I want you to revolve it about the x-axis, or I want you to revolve it about the y-axis. So I'll let you know that also. But you can see what happens. And so now, remember in chapter 5 and in 6.1, in chapter 5, finding the area under the curve, we came up with little rectangles and we did the summations. Do you remember? That's what an integral is. It's summing up those little areas of the rectangles. Well, now what's going to happen is those rectangles are going to turn into discs. And you can see the progression in figure 619.1, which is what we did in chapter 5, versus 619 figure 2, which is what we're doing now. We're just going from two-dimensional to three-dimensional. So now, instead of finding area, we're going to find volume. We're going to find how much volume is in that disc. So if you go over to page 315 and you look at the volume of a circular disc, you can see that it says volume is equal to pi r squared. That should sound very familiar to you. Pi r squared is going to be your area of a circle, times the thickness. That's where you get your volume from. Now, if for our purposes, the thickness is your dx or your dy. That's where your integration comes into play. Okay? So, if you go to your formulas page for the DISC method, number 1, you'll see the volume V of a solid of a revolution generated by revolving R about the x-axis. We're taking our region and revolving it about the x-axis. You're going to have the integral from A to B. That doesn't change. The integral from A to B. And then you have your pi times your function, which is your radius, squared, and dx is where the thickness comes into play. Okay? So, if you're revolving around the x-axis, you have x boundaries, you have x variables and constants, and the only thing new is the pi and the square. Okay? And that should make sense because we're going from area to volume. We're just stepping it up a notch. So basically, if you can remember pi r squared, you're good. All right. So for the DISC method around the x-axis, you're still going to have your x boundaries and your x variable on your constant. Now, if I ask you to rotate this about the y-axis, you're going to have the y boundaries. Throw the pi in. Please don't forget that pi. Throw the pi in, and then you're going to have your function with respect to y squared dy. Okay? That is the DISC method. If you have a graph that will make a solid three-dimensional figure, you will use the DISC method. Okay? So let's look at one. Here it says, find the volume of the region bounded by the graph of y equals the square root of x equals 4, and y equals 0. This is new. Revolved about the x-axis. Revolved about the x-axis. So if I tell you to revolve it about the x-axis, you already know which formula you should be looking at. Yes? You should already know which formula you're going to be looking at. All right, so let's do a graph. Y equals the square root of x. Now let me ask you something, because we're going to talk about this again tonight. We talked about it last Wednesday. If the square root is already in the problem, Do you have to take into consideration the positive and the negative of the function? No. Only when you introduce the square root, only when you take the square root of both sides, are we going to deal with the positive and the negative. Okay? So, y equals the square root of x. You know that graph. It goes like this. X equals 4. That's just a vertical line going through the x-axis at 4. And y equals 0 is your x-axis. So this is two-dimensional. And this is what I want you to do. If this is the two-dimensional drawing, and I take this two-dimensional drawing and I revolve it around the x-axis, can you give me a real-world shape that's similar? A cone, a dome, a bullet, half of a football. I'm trying to think of all these things here. Okay, so you got that shape in your head? We're going to find the volume of it. We're going to find the volume of it. All right, since we're integrating about the x-axis, what boundaries do I need? X boundaries. Can you pick out your x boundaries? From what to what? From 0 to 4. Now, going back to area, when we had an r sub x region, what did we do? Top minus bottom, right minus left. What did we do? R sub x region, we did a top minus bottom. What is the top function? The square root of x. Yes, the square root of x. So we'll have the top. What is the bottom? Now what have I left out? This is not the formula. We have to have a pi and this radius squared. Don't forget that. Pi r squared. All right, so let's clean this up. Can you tell me a number for pi? 3.14. It's a constant. What do you know that we can do with constants when we integrate? We can always take them out front. So, from this point forward, this is what I'm going to do. I'm going to bring my pi out front. I don't have to worry about the 0, thank goodness. And I'm going to change my square root to what? And this is the proper way we're going to write. So we can bring our pi out front because it's just a constant, 3.14, blah, 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 blah. So we're not even going to integrate that. And then we have our radius. Now when we talk about the radius of this thing, the radius is made by that half parabola function. That's what your radii are made by, each one of those slices. The radius is made by that square root of x, x to the 1/2. And then we're going to square it. What happens if you square x to the 1/2? Yeah. When you have a power 2, a power you multiply, right? 1/2 times 2, or half of 2, you get 1. So we're going to have the integral from 0 to 4 of x dx. Integrate. Looking at your... Let me pause this for just a second. Okay, so let's take the antiderivative. We're going to have pi times the antiderivative of x is going to be what? And we're going to go from 0 to 4. Okay? So we're going to have pi times 4 squared over 2 minus 0, of course, if you want to put it in there. 4 squared is 16. 16 divided by 2 is 8. 8 times pi is 8 pi. Now, just out of curiosity, so you know what you're doing here, what are the units? Units for volume cubed. We're stepping it up a notch. Okay? So we're going to units cubed. questions? These are not that bad because, number one, I'm telling you which axis to use. And when I tell you which axis to use, that tells you which formula to use. All you got to do is find your boundaries, plug in your function, and go with it. Okay? Not that bad. All right, let's go here. Find the volume of the region bounded by this stuff revolved about the x-axis. Revolved about the x-axis. Let's see if you can set it up. Again, if you don't need the graph, that's fine. Some of you are going to get so good at this that you won't need the graph. If you don't need the graph, fine. If you do need the graph, then by all means graph it. Y equals x squared plus 3. That's going to be your basic parabola shifted up 3. And then you have x equals 0, which is going to be your y-axis. And you have x equals 2, which is going to be a vertical line going through the x-axis at 2. And then you have y equals 0, which is your x-axis. So this is the region that we're going to rotate. And if we rotate this, it's going to look something like this. So this is your three-dimensional figure. It's kind of like one of those things that the wheels, what are those things called? The drum things with the wheels. No. What it looks like? Or a cymbal, I guess. A drum cymbal. What are those wheel things called?
Drums in wheels?
Is that what it is? Okay. I don't know. I just seen them. I don't know what they're called. I just seen them. All right. So let's find the volume of this thing.
Let's rotate this way. Right?
About the x-axis. Yep, we're going this way. Because look, here's the top half of that graph, and we're going to rotate it. There. You see it? It's a what?
It's a bit.
Oh. Okay. I see it. Y'all must be hungry. Okay, so revolved about the x-axis. Do you have it set up? Should. You should already have it set up. So let's bring our pi out. How do I know which formula to use? If it says volume, you have pi r squared. If it says volume and it says disk, you have pi r squared. Okay? So you're going to have pi times the integral. What are my boundaries? 0 to 2. What is the function? Good. So is that how you set it up? Yes, no, maybe? Should be. Okay. Let's see how much algebra you know. Do you know how to square a binomial? Is it x to the 4th plus 9? No. Absolutely not. Square, double square, or expand and pull it. However you want to do it. Completely and totally up to you. So let's do the algebra. If there's one thing that you learned in Cal 1, it should be try to do some algebra before you get into this. Not to mention the fact we don't have a chain rule for this. We don't have a product rule. So you got to simplify it or do a U substitution, which that would be erroneous here. But anyway, it would work. Okay, square double square is what I'm going to do. So we're going to have x to the 4th plus 6x squared plus 9. And we're going to integrate with respect to x. What do I do? Well, I did this. Okay. All right, now we can integrate. So we'll have x to the 5th over 5 plus 6x to the 3rd over 3, and you know that's going to cancel, plus 9x from 0 to 2. 3 will go into 6 2 times. All right, let's go ahead and plug in. So we'll have 2 to the 5th over 5 plus 2 times 2 cubed plus 9 times 2. And the 0 is not going to matter here. So if we do all this, plugging it in the calculator, we're going to have pi times 32 over 5 plus 16 plus 18. Keep punching it in, and you should come up with what? Does anybody have it? 256 pi over 15 is what I came up with. Now, if you go ahead and type the pi in, if you do 256 times pi, frequent 1/4, whatever, and you come up with a decimal point, that's fine. I'm not going to mark off for that. Oh, but you know what? Oh, yeah, that's right. Questions? Well, let's try that again. Did you come out with 202 pi over 5? Okay. Sorry about that. I was looking at the next problem. Now you know the answer to the next problem. Can't give that one as a bonus problem. Okay, so are we good on setting this up? Now, if I ever, and I don't intend to do this, but you never know, if I ever give you a test and I don't say use the disc method or use the washer method or use the shell method, how would you know to use the disc method? If you take a two-dimensional figure and you revolve it about an axis and it makes a solid, you're going to use the disc method. Okay? All right, let's take this one and revolve it around the y-axis. So again, these graphs, especially the x equals y squared minus 4, that's going to be backwards to you. This is going to be with respect to the x-axis. So typically we would move this down 4, but since it's backwards, we're going to move it to the left 4. So it's going to look kind of like this. And then you have x is equal to 0, that's going to be your y-axis. And y is equal to 0 is going to be your x-axis. Now, when you do this one, we don't want the bottom half. Can you tell me why? I've already talked about it tonight. Why do we only want that top half? Well, think about it. If we're going about the y-axis, if we revolve this about the y-axis and we did the top and the bottom, then we would have some crazy stuff going on, right? We would have double what we actually need. Okay? So be careful with that. Look, when you have boundaries, look at this. I have a boundary that splits this graph in half. That's no good. We haven't done anything like that at all. Okay? So if you have a boundary that splits it in half, don't double it. Instead, take the bottom half away.
You could use either half though, right?
You-
Technically?
Yes. I think the bottom half would give you a negative though. I don't know. We'd have to play with it on one of your nerd days, figure it out. Okay. So, we're going about the y-axis. So since we're going about the y-axis, we're going to have pi. What are my boundaries? Zero to what? How would you figure it out? We've already talked about this tonight. Well, okay, guys, look. You're looking for this point right here, yes? What is the x coordinate of this point? Because the y coordinate is the one in question. That's our boundary, right? What is the x coordinate of this right here? 0. So where are we going to take this 0 and plug in? Right here. If I plug 0 into this and I do a little bit of math, I'm going to get plus or minus 2, but we don't need plus or minus 2. We need 2. So it's going to go from 0 to 2. If you cannot look at your graph and figure out what your boundaries are, go to algebra. Use some algebra. You're wanting a y boundary, so plug x into your equation and come up with the y. You're looking for the new y. So you have 0 to 2. All right. What function makes this? But now, wait, time out. Let's answer this question first. We're evolving about the y-axis. So are we doing top minus bottom or right minus left? We're doing right minus left. So what is this going to be? What function are we going to use? It is going to be 0. I'll just write it. It is going to be 0 minus your y squared minus 4, but it's all going to be squared. So what's going to happen with that minus anyway? It's going to go to plus. So essentially what you're looking at is this. All right, do the algebra. Let's go. Push a pencil. All right, so do the algebra. Square, double square, or expand it and full it, either way. And then, of course, you have to do the integration. Don't forget the little s symbol means to integrate. Do the antiderivative, which is where y to the 5th over 5 minus 8y to the 3rd over 3 plus 16y came into play. If you want to move that 8 out front, you can. If you want to move 16 out front, you can. However you want to do it. And then from there, it's just plugging it straight into the calculator. And again, if you want to leave it in terms of pi, that's fine. If you don't want to leave it in terms of pi and you give me a decimal answer, that's fine too. However, on the final exam, I will specify leave in terms of pi or give me an approximate answer. One of the two. Are we good? Questions? Okay. Try this one. Since we are revolving about the x-axis, we do need x boundaries. So my x boundaries are going to be, we've already talked about, from -2 to 0. If we graph this, that's fine. And then you have x equals -2. And you have y equals 0. So the region that we're talking about is this, but we're going to take it and we're going to revolve it about the x-axis. So you kind of have something that looks like that. All right, so for my x boundaries, we're going to go from -2 to 0. Now, when I plug this in, since we're talking about volume, we know that we're going to have the pi, and you're going to have the radius. You're talking about x-axis, so you're going to have right minus left. What is your right side boundary? Which, so when we set this up, right minus left, what are we going to have? Which graph is the one on the right? All right, so we'll have x to the 3rd minus what? So, do you think this is right? Well, if you're revolving about the x-axis, so are we doing right minus left or top minus bottom? Then why are you telling me right minus left? Okay, so let's try this again. You're revolving about the x-axis, therefore you need x boundaries. When you do this, it's going to be top minus bottom. R sub x boundaries, top minus bottom. Please don't get that confused. You're sitting there telling me right minus left. We're not doing an R sub y region. We're doing an R sub x. Top minus bottom. Top minus bottom. Now, what is the top? 0, yes. Minus what? Which essentially is going to turn into what? X to the 6th dx, right? What's your next step? Antiderivative. Integrate. To get rid of the s, to get rid of the integral symbol, you have to take the antiderivative. So we're going to have pi times x to the 7th over 7, evaluated from -2 to 0. Now what's different about this one? Zero's on top. That just throws a wrench in everything. So, don't forget, we're going to have pi, and it's always the top, 0, but top boundary minus the bottom boundary. So we're going to have 0. You have to use the 0 this time. 0 minus, and then when you plug that -2 in, be very, very careful. So you're going to have pi times -2 to the 7th power. What is that? 128? But then you have a minus sign, so it's going to go to positive 128 over 7. So you have 128 pi over 7. Please don't get that confused. If guys, and I don't say this to be ugly, I say this to give you fair warning and fair heads up. If you get that test 1 week from today, and you get you get the top minus bottom and right minus left messed up, you'll make a 0 on the test. Please don't do that. Okay? If you're looking at x boundaries, it's top minus bottom. If you're looking at y boundaries, it's right minus left. Okay? Don't forget that. Please don't forget that. All right, let's do this one. Find the volume of the region bounded by the graph of y equals 1 over x, y equals 1, y equals 3, and x equals 0. And look, we are revolving about the y-axis. Y-axis. So we know that we have pi times the integral from 1 to 3. Now, let's graph that and figure it out. 1 equals 1 over, or y equals 1 over x. Do you remember what that is? We did it last week. Y equals 1 over x. Remember, this is your hyperbolas in quadrants 1 and 3. Even though the quadrant 3 is not really going to matter. Y equals 1 is here. Y equals 3 is here. And x equals 0 is here. So that's what we're looking for. Okay, so since we're revolving about the y-axis, are we doing top minus bottom or right minus left? What is the one on the right? 1 over, oh, right. Has to be in terms of y. Since we're doing y-axis, it does have to be in terms of y, so basically you, multiply by y, or x, and then divide by y. So basically the x and the y change places. And then minus 0, because 0 is your right side boundary, so we don't really worry about that. I mean, I'll write it in there, but. Okay, so we have pi integrated from 1 to 3. If we square that, we're going to have 1 over y squared dy. Tell me how to integrate that. Yes. So we're going to have pi times the integral from 1 to 3 of y to the -2 dy. So we'll have pi, doing the integration, we're going to have y to the -1 divided by -1 from 1 to 3. Let's clean that up just a little bit before we start substituting in. That's going to turn into what? -1 over y, right? All right, so we're going to have pi times -1/3 minus -1 over 1, which is going to be -1, so I'm going to go ahead and change that to +1. Hope that's okay with you. All right, so 1/3 minus 3. What are you going to get? Or 1/3 minus 1, or +1 rather. I'm tired. Yeah. 2 pi over 3. 2 pi over 3 is what you should be coming up with. How do we do? You've got to know how to set these up. When you look at these, it cannot be Greek. You got to have it straight in your brain. Got to. Okay, what I want you to do is I want you to go to, in your book, go to page 317. Go to page 317. And I want you to compare figure 624 with figure 625 2. What do you notice? If 624 was complete, it didn't have that section taken out of it, what would be the comparison between 624, figure 624, and figure 625 2? For those of you who do have a book, compare. What can you tell me?
Oh, it's similarities or
Different. One's around the y, one's around the x. Okay, let's take the x and y completely and totally out and tell me. One is solid, and the other one has a hole in it. One is the disk method, and one is the disk method, and the other one is the washer method. Okay. So now what's going to happen is this. Instead of one of our boundaries, instead of our boundaries making this figure solid, in other words, when we revolve it about an axis, instead of it being solid, it's going to have a hole in it. It's going to have a hole in the middle of it. So we don't have a disk anymore. Instead, when you have a disk and you take the center out of it, it now makes a washer. Okay? And so now what we're going to do is the disk washer, or now we're going to do the washer method. On your formulas page, number 2, you see washer method. The only difference, okay? The only difference is this. Back when you took geometry and you had 2 figures, and let's say you had a circle inside a square, and I wanted to know the area of the square, the portion of the square that's left when you take the circle out. You know what I'm talking about? When you had in geometry, if I asked you what is the area of the shaded region, what would you have to do? You'd have to find the area of both of these and then subtract them, right? The exact same thing. We're going to do the exact same thing. Kind of, sort of. Look over on page 320. Nope, going too far, sorry. Look up page, 318. And you see 6.9, the volume of a washer. The volume of a washer, now look how close this is to what we just did. The volume of the washer is your pi. Remember we did pi. Your outer radius squared, which is your function, minus your inner radius squared, which is another function. Okay? And so that's what we're going to do. Again, I will tell you which axis you're revolving about. So, of course, if you're revolving about the x-axis, you're here. If you're revolving about the y-axis, you're here. That's not going to change. All right. And on your cheat sheet, you can see you have an R sub x region and an R sub y region. The hardest part about these is figuring out which function is going to come first. That's the hardest thing. Okay. You should already have it in your head R sub x regions versus R sub y regions. You should have that in your brain by now. Lord knows I've drilled it into you. So now let's take it one step farther and see if we can figure out our bigger radius, our outer radius, minus our inner radius. Okay? Taking that whole out. Alright, so here. Find the volume of the region bounded by these graphs. You have x plus y is equal to 1. We'll graph this one. So x is 1, y is 1, and you have this line right here. And then you have x minus y is equal to negative 1. So x is negative 1, y is 1. And so you have this line here. And then you have x equals 2, which is the vertical line going through the x-axis at 2. Revolved about the y-axis. So you're thinking, how in the world is that the washer method? In your brain, take this triangle and revolve it about the y-axis. Can you do that? I will try. It's going to make a cylinder. But what's going to happen inside that cylinder? It's going to be reamed out. And this is why you have the washer method. Because when you make concentric circles about the y-axis, this center part's going to go away. That's why you have the washer method, because we're going about the y-axis. So you have the center part gone. Okay, so we're revolving about the y-axis. So we know that we're going to have the pi times. Now, we need y-axis boundaries. What can you tell me about this figure? If we're revolving it about the y-axis, we have, now look at this, okay? We have some of the figure above the x-axis and some of the figure below the x-axis. That's no good. That's no good whatsoever. So what are we going to do? Let me help you out. Now what can you tell me? It is symmetrical. It is symmetrical. So we're going to multiply this times 2. But we're only going to do half of it. Hence, multiplying by 2. Now, why did I do that? If I saw that on the test, how in the world would I know to do that? Because you're going below the x-axis. We have some negative volume in there, along with that positive volume in there. And we don't want to do that. We do not want to do that. Okay, so how am I going to figure out where, now we're revolving around the y-axis, so you know it's going to be right minus left, right? Revolving about the y-axis is going to be right minus left. So I've got to have y boundaries. How am I going to figure out what this boundary is and what this boundary is? Okay, to get this boundary, which two would I set equal to each other? Which two intersect at this boundary? The two lines. The two lines. You can set them equal to each other, or what could you do? I think it would be easier to do this. A system. I think that would be easier. So if x is equal to 0, y is equal to 1. So that y boundary, that lower y boundary, is going to be 1. Now how am I going to figure out the upper boundary? Where do these two, look, here's the upper boundary. Where do these two lines, or what two lines intersect here? Which two lines is this? This one and this one. So how am I going to find the y boundary? Plug 2 in for x and solve for y. So what is y equal to? 3. Okay. All right, so now we have our boundaries. Next thing we got to do is figure out what? Y-axis boundary, so we're doing right minus left. What is the right side function? 2. What is the left side function of that top half only? I'm hoping you said, well, we got to solve it, right? We need it in terms of y, right? So let's take and solve this for y. X plus 1. Snotty pickers. No. That's not right. Why is that not right? Because I need y. So let's solve for x. There we go. Do you see how I fought my way through that? Do you see how I found my mistakes? I knew that this is a y-axis boundary, so I knew that I had to do dy. Well, you can't find the antiderivative of x with respect to y. You need all y's. You need y boundaries, you need y variables, you need constants with respect to y. All right, the rest you should be able to do. So, we have 2 pi, integral from 1 to 3. 2 squared, of course, is 4. This one, be careful. All right, so clean it up. You see what I did? You have negative, you distribute the negative through, of course. You have negative y squared plus 2y minus 1. And then combine the 4 and the negative 1. That's where the 3 comes from. It's just algebra. Integrate. So we'll have 2 pi times. Now this time we don't have a 0 boundary, so we are going to have to take both of these into consideration. We'll do the top, so minus the bottom. All right, so if we put all that into our calculator, (32π/3). Now, while you're finishing up this problem, just kind of listen to me as you're doing this. Had this problem not been symmetrical, you would have had to have done two different integrals and then added them together. You would have had to have done from 0 to 3 plus that bottom boundary, whatever it would be after you set those equal to each other, after you set the x equals 2 and the, well, we can do that right quick. You'd have to, so it'd be -1 from -1 to 0. Integrate both of those, add them together, and you would still come up with 32π/3. So if you didn't want to use symmetry, you wouldn't have to. But you have to understand, because it falls below the x-axis, you would have to do two different integrals if you did not use symmetry. Okay? So be careful with that. Because a lot of people on this test, they would find the volume of this figure by integrating from -1 to 3 and not taking into consideration that you have two different volumes going on there. Okay? So just be careful with that. Play around with it. I mean, you know, on one of your study days or whatever, play around with it. Questions? What's wrong? Calculator. Okay. We can overcome the calculator. But the calculus part you're okay with, yes? Okay. Anybody? Speak up for now. Anything? Okay. Next week, what we will do